Hi, good morning everyone. First of all, I'd just like to ask that we give a round of applause to the organisers, HISA and Situation, and our sponsors. Thanks very much to all of you for putting on together. Yeah, this wouldn't be possible without them. So this talk that I'm about to give, I stole the title from Martin Fowler. Martin Fowler calls all his talks this, so that he doesn't have to write a new abstract. He just gives everyone the same abstract, so I stole his idea. This talk basically evolved from when me and Dave were writing the Continuous Delivery book. I was actually a product manager at ThoughtWorks, and ThoughtWorks is one of these companies that has basically applies the Peters principle to management. Who's heard of the Peter principle? Okay, most of you. So Peter principle is basically you keep on promoting people until they no longer have the skills to succeed at their job, and then they fail. So I got made a product manager, and they're basically like, you seem reasonably smart, you'll be fine, get on with it. And I was like, okay. So I looked at Scrum, and Scrum basically says, you're the product owner. The product owner is a black box who prioritizes things and then turns up at showcases. And I was like, okay, I guess I'll write lots of stories and I'll prioritize them and I'll turn up at showcases. And it was really easy to write stories. I wrote tons of those things. It was amazing. And handed them out, and we built stuff. And you know, I was quite pleased with the product. I was like, this is an amazing product. People would be crazy not to use this. People didn't use it, so that was a bit disappointing. And you know, eventually the product, I mean, it still exists today. It's doing pretty well, but certainly wasn't the kind of roar away hockey stick Silicon Valley success I was hoping for. And so when I finished that job, I basically spent several years kind of trying to work out how I could have done a better job. And now I teach a whole course on this at UC Berkeley. Basically, it's therapy from kind of post-traumatic stress disorder from having been a product manager for 3 years, which is the hardest job I ever did, really, really stressful. So this is kind of a condensed version of that. 3 things to skip right to the end, in case you want to spend the next hour playing Tetris on your phone. Number 1, we talk about projects a lot. Projects are a shitty model for building innovative products. We shouldn't be doing that anymore. It's a terrible idea. Secondly, we talk about this conference is about continuous delivery, but you have to address the whole value stream, everything from the fuzzy front end all the way through to post-delivery support. Adrian Cockcroft likes to say that your product is done when it's retired, which I think is actually a very important point. We need to plan for the whole life cycle of the products we build. And people spend a lot of time thinking about tools. Normally the problems are process and culture. That's normally the things that go wrong, and that's what I'm going to be spending a lot of the time on today. So, first of all, the project model. Projects are designed fundamentally for building things that once they are built, they do not change very much. Once we've done the planning and we start building them, we don't discover significant information in the course of building them, because, you know, obviously, if you do that and you have to change the plans, that turns out to be very expensive when you build bridges or buildings. And finally, where they must be completed before we start using them. None of these 3 things is true about software products. Software products, if they're successful, they will change considerably over their life cycle. Secondly, in the course of building software products, that's when we discover the most about what will happen. In the planning phases for software products, we have the least information we will ever have about our users and their needs. And third, we can start getting users using our products well before they are, in any sense, done. And the whole idea of a minimum viable product is to say, let's build a really fabulous product that solves a problem for a very small target audience and get those people using it and then build out. Not, by the way, build a shitty product for lots of people and then make it usable once you've got some users, which is a common misconception. But let's build a product that's very good for a very small segment of the market and then build out. So the project model is fundamentally flawed. And yet it's still the basis of a lot of the way that we do software delivery today. Who's working in companies where everything you do is basically driven by projects? That's like 2/3 of you, 3/4 of you. So it's incredibly problematic, and there's a huge impedance mismatch between traditional project management or even agile project management, which I'll talk about a bit later, and the way that we should be doing software product development with an experimental mindset. So, I mean, for many years there was the methodology wars. This is a chart I stole from when I was consulting at ThoughtWorks, and we went to Japan and I spoke at Agile Agile Tokyo, and that was a really weird experience, because you go to Japan, and they're basically, everyone's doing waterfall, and you're like, so, you know this lean thing that you all invented? You can use that for software. And they're like, what? No, never work. And so this was kind of a project plan, which is kind of heavily anonymized for a company I went to visit when I was in Japan. And you can see, you know, it takes about 6 months to go through the product development process. This is kind of the V model. I don't know if you can read that at the back, probably not. I can barely read it here, but like it's basically like requirements, analysis, change, development, integration, acceptance. And this is for, you know, consumer electronics products. But look, here's the thing. If you release it and your users don't like it, you can't even fix it in the second release, because by the time the first version's released, you've already finished the requirements phase for the second version. So you've then got to wait a year to get a new version out that incorporates the feedback taken from the first version. So this is, you know, it's nonsense. You can't possibly build compelling, innovative products using this model. And Agile was basically an attempt to change this, to say, well, actually, we need to be comfortable with uncertainty, and we need to not think that once we finish the planning phase, we're done, and we shouldn't, you know, any further change is bad. Although, who's been in an organisation where scope creep is a dirty word? Right, scope creep is your customers telling you did it wrong, and that's actually really good news, because we should expect that if we're building anything innovative. Nevertheless, despite this, many of us are still operating in a world, and I saw this all the time as a consultant. You know, we're going agile. Everyone does the 2-day Scrum training course, and now we're taking orders from management standing up rather than sitting down. And that huge backlog of work we can't ever complete is now prioritised and estimated, and now we're agile. Hooray! But what typically is the actual product development process is something that Dave Weston Forrester likes to call water, scrum, fall. Where basically, yeah, we're doing iterative development in the development part of the life cycle, but we still have the fuzzy front end, and this typically takes many months to go through. You know, someone comes off the golf course with a new idea, we have to build some enormous requirements document, it has to go through the budgeting process. Once the budgeting process has been finished, then we have to, you know, do estimation, all this kind of stuff, to put these very detailed plans together. And then at the end, we've got this whole thing where we're doing integration, testing. Hopefully we manage to fix some of the bugs that we found in testing if we're really lucky. And then we toss the whole thing over the wall to IT operations to run that thing forever. And so if you change this bit in the middle and make it agile, in terms of the overall cycle time from golf course to measurable customer outcome at the bottom here, typically making this bit in the middle agile only gives you about a 5% increase, 5% decrease in cycle times, that kind of order of magnitude. You're not looking at kind of order of magnitude change in terms of the overall time through this loop. You know, and even if we're working in iterations here, we're often not releasing to users at the end of every iteration. Who actually releases new software to their users once a month or more frequently? Wow, that's loads of you. You're an advanced crowd. Who's releasing more than once a day to users? Okay, that's a smaller number. I would say that's like about a fifth of you or so. Who's releasing less frequently than once a year? Anyone? Okay, there's a few of you. Okay, thanks very much for putting your hands up. It's probably not something that you're terribly proud of, but it's the reality in a lot of places still, and I think we have to respect that it's very hard to do this stuff. So in a lot of places, this is still the reality of product management and the way we build things. And the title of the book that me and Dave wrote actually came from the first principle of the Agile Manifesto. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. And for this talk, I'm not actually going to focus on the continuous delivery bit. You're going to see plenty of awesome talks about that. I'm going to focus on the valuable software bit. And this important question, what is value? Everyone says, you know, we should prioritize by value. What is value? What does it mean for something to be valuable? How can we measure that? And that has bothered me for a really long time. And so I went and looked at the models for how we measure value. Everyone hopefully is familiar with the idea of shareholder value. Shareholder value is actually, opinion is divided on this. Some people think that you can actually sue companies if they don't act to maximize profits for their shareholders. Some companies have basically ignored this. Google and Facebook. Facebook very notably said we are not interested in maximising shareholder value. But this is kind of the dogma of, the US public company, and it actually doesn't go back that far. It comes from a paper by a couple of people called Jensen and Meckling, Theory of the Firm, a couple of academics who basically posited this as a theory, and it was very rapidly adopted and became the dogma. Turns out to be a terrible idea. There's been lots of research into companies that actually placed their highest priority on profit in their mission statement, and research shows that those companies were universally less profitable than people who didn't place profit as the highest, most important thing in their mission statement. So focusing on profit as your most important thing is a guaranteed way to not maximise profit. So that's unfortunate, doesn't work. And in fact, this model has presided over a decline in the rate of return, both on equity investment and investment capital. However, some people have done very well out of this. Can you guess who they are? Managers, absolutely right. It's been accompanied by an 8-fold increase in CEO compensation from 1980 to 2000. So, you always look for who benefits from this model, basically. There's a really good quote from Jack Welch, who was CEO of GE for a while, salty fellow who I wouldn't say I universally admired, but I love this quote. Shareholder value is the dumbest idea in the world. Not one to compromise, Jack Welch. It's a result, not a strategy. Your main constituencies are your employees, your customers, and your products. And I think this is gold. And the order in which he's actually put these things, I think, is also gold. Your employees, your customers, and your products. These are, I believe, words to live by. So if you're not going to put shareholder profit maximisation in your mission statement, what might you put in your mission statement? So who knows what this is on the screen now? That's the Dragon, that's right. That's the first private vehicle to dock with the International Space Station, made by SpaceX, Elon Musk's company. Let's have a look at their mission statement. The company was founded in 2002 by Elon Musk to revolutionise space transportation and ultimately make it possible for people to live on other planets. That's a cool mission statement. I like that mission statement. And this isn't the only thing that Elon Musk has done. In his copious free time, he's built Tesla Motors. Anyone pre-ordered a Tesla 3? There's one person up the way. Yeah, once the second edition, it's like buying a Mac, right? I'm not going to buy the first edition, I'm going to buy the second release. So their mission statement, Tesla Motors was founded in 2003 by a group of intrepid Silicon Valley engineers who set out to prove that electric vehicles could be awesome. That's a great mission statement. Now, you don't need to be Elon Musk to be fabulously successful, although it helps. I want to talk to you about this dude here, Jack Andraka. So he was a 15-year-old from Maryland who won Intel's Science Fair in 2012 by making a diagnostic tool for pancreatic cancer after his uncle died from pancreatic cancer. It detects a protein commonly used as a biomarker using carbon nanotubes coated with antibodies. It's 100 times more sensitive than existing diagnostic tests, 168 times faster, 26,000 and a bit times less expensive, and 400 times more sensitive. So this is basically a 15-year-old who blagged his way into a lab, read a whole lot of papers on Google, and built a diagnostic test using carbon nanotubes coated with antibodies. So, I have 2 kids. I would quite like my kids to turn out like Jack Andraka. So I kind of went and did some research to find out what his parents' kind of child-rearing philosophy was. And I found this interview where Jack talks about his parents. He says, his parents never really answered any of the questions they had. Go figure it out for yourself, they would say. I got really into the scientific method of developing a hypothesis and testing it and getting a result and going back to do it again. Now, as a parent, this is great. I can pull this off. So, I think I've got my whole strategy for child development sorted. Thanks, Jack. But, I mean, to be a bit more serious, the scientific method is really important here. The idea of coming up with a hypothesis, designing an experiment, saying what you think the results will be, running the experiment, gathering the data, and then working out what to do next. This has been epitomised in kind of one of the great Silicon Valley kind of methodology breakthroughs in the last few years, the lean startup. And you can see the trendy kind of Silicon Valley kind of lime green and kind of, I don't know what you call this colour, like cerulean or something. But it's a very trendy diagram. You know, the build, measure, learn loop, and the idea is that productivity, the only productivity metric that matters is how fast can we learn, which is how fast can we go through the loop. But really, this is an idea that's several hundred years old, which is basically the scientific method. We're going to create a hypothesis for our product. We're going to deliver the minimum viable product. That's an experiment designed to validate your most risky assumptions about your product. Then you get feedback from real customers, and then you repeat. But there's a problem with that, which I think probably English people tend to appreciate more, which is that basically sounds like a load of crap. Especially like for many years, you know, architects will basically be like, and people who have to use computer products, they're like, well, you know, buildings don't fall down. Bridges don't fall down. Why can't computer programs be more like that? Why can't we build things that are fundamentally reliable and don't break all the time? And so, who's been to this building? Okay, lots of you. So this is the Sagrada Familia in Barcelona, which is built by, or designed by Gaudi. It's still not finished yet. And Gaudi had a joke about that. He says, my customer is not in a hurry. And this was really revolutionary at the time. It features architecture where there's actually lots of hyperbole in the structure of the design. And that was revolutionary. At the time he was building this, people were very keen on straight lines in architecture. You know, and if you were feeling a bit daring, you might put an arch into it, because that'd been known to work for many years. That was architectural innovation introduced by the Arabs who came through and invaded Spain earlier on. And so he was doing something which was very, very unusual and very strange, basically because he was a bit awkward as a child, maybe something a few of us in the audience can empathise with, and he spent a lot of time out in nature and saw kind of these hyperbolic structures in the way that animals and plants grew. And so he was like, well, this is obviously quite a good idea. Why don't we use this as a basis for architecture? But he did not go and just design this thing and start building it. If you go down into the crypt of Sagrada Familia, you'll see this model, where basically what he's done is, this is an earlier church that he built using his kind of hyperbolic architecture style. And what he did was basically create this model where he put the whole thing upside down and used weights to simulate the loads on the structure, so that he could do basically load testing at a much smaller scale than the actual building. And if you go around the crypt, you'll see there's loads of scale models, and he's found really smart ways to test out his ideas in much smaller scales to validate his hypotheses about whether the structure is actually going to stand up before building it. So this idea of an MVP and building much smaller tests is actually something that Gaudi was doing in real life. And that was very important, his ability to make sure that he was going to build these things and they weren't going to fall down. If you're building a truss bridge, which has very well understood architectural characteristics, you can basically plop an algorithm into a computer and get out your truss bridge based on a few design criteria and be pretty confident it will stand up. That's not the case if you're building new architectural designs, and it's certainly not the case if you're building new products. Anything that you're doing that's fundamentally innovative, you're not going to be able to plan the uncertainty out of that thing, either in terms of the architectural decisions you make, and certainly not in terms of the product decisions you're going to be making about whether someone will actually use it, which is usually the biggest uncertainty. Apple is often held up as a counterexample to this. You know, this is not the latest one. But you know, basically the mythology of Silicon Valley is that this kind of emerged fully formed from the mind of Steve Jobs. But who knows what the very first computer is that Apple made? The Apple I, correct. So here's the Apple I. Bit different. And so, you know, this is much more like an MVP. It's basically a circuit board that was built allegedly in his garage, although apparently he actually built it at HP, but they were very careful to nix that in case HP claimed it's their intellectual property. And that's total but it's a rumour. And actually there's a really good website where you can see a bunch of stories from the building of the Macintosh called folklore.org. My favourite story from the building of the Apple Macintosh is this one. Instead of arguing about new software ideas, we actually tried them out by writing quick prototypes, keeping the ideas that work best and discarding the others. And this is my favourite bit. We always had something running that represented our best thinking at the time. We always had something running that represented our best thinking at the time. And in fact, one of the biggest kind of innovations in building the Mac, this guy called Burrell Smith was the hardware designer. He designed the logic board. And he basically used PAL chips where you could reprogram them electronically. And lots of PAL chips, there were several of them. And the reason he did that was so that you could change the way that the logic worked on the logic board without having to build a new logic board. So his use of PAL chips was basically so that he could keep evolving the design of the logic board in this very iterative way so they could experiment with new ideas and innovate much more rapidly. So it went all the way through the thinking about how the Apple Macintosh was designed, this placing of the ability to iterate rapidly on the design and the software at the centre of how they did product development. It's very, very important. As compared to the Lisa, Lisa was very much more plan-driven. It was kind of very waterfall in its building. So, who's familiar with user stories? As a, I want so that, yay! Okay, almost all of you. Okay, so, user stories are great, I like them. But fundamentally, in terms of implementation, and certainly in a lot of the scaled agile frameworks you see today, there's this fundamental idea that, someone upstream writes the story and then hands it to the developer, and the developers are like, what's the point of this? Don't worry about that. Just build the story. And you're basically fundamentally building the thing, and you don't really have much chance to say, well, this story is rubbish, this is a terrible idea, let's go and change that. So how many of you have been in that situation where you fundamentally don't get to question the assumptions of the people who are giving you the work? Okay. Quite a lot of them. And this, unfortunately, is the reality of Agile today. We've kind of got a lot of artifacts, and we're following, we're kind of cargo culting a lot of what Agile tells us. But fundamentally, it's still very much, a one-way flow of information through the system. And even the scaled Agile frameworks, I think, really suffer from this problem. You still see this idea that at the program level, we have epics, and we break down the epics into features, and they get broken down into stories. And then we kind of hand the stories out to the development teams, and the development teams all build the stories, and then you assemble it all together at the end of the release, and it doesn't work. You're like, oh, that's unfortunate. And everyone's like, well, I did my job. Those people over there, and they're like, what are you talking about? We did our job, we did all these stories. And the reality is, everyone did their job. Everyone did the stories they were given, and they put them all together. And the problem wasn't that people didn't do their job. The problem was that those things weren't the right things to do in the first place, and we made a bunch of assumptions about how the thing would work, which turned out not to be true. Because we're building complex systems, and you can't just plan out the uncertainty in those things. So anytime you're in that situation where people are like handing you a bunch of cards or requirements or whatever, and you're like, I've got some questions about this, and they're like, shut up and build the stories. Like, that should be sending off big alarm signals in your head. And you should, Martin Fowler has this saying, change your company or change your company. That should be setting off big alarm bells, basically. I really like this template from Jeff Gothelf, who wrote the Lean UX book. He talks about hypothesis-driven delivery. We believe that building this feature for these people will achieve this outcome. We'll know we're successful when we see this signal from the market. What's the signal from the market we're looking for that will validate our assumption about whether the thing is actually useful in the first place? And I really like this. This word requirements really annoys me, because whose requirements are they? Are they the user's requirements? Typically not. Users don't know what they want. Users know what they don't want once you've built it for them. They're normally the requirements of the hippo, the highly paid person with the money who's giving you the requirements. They're my requirements. I require them. And I think thinking about hypotheses is a much more scientific way of thinking about program management, especially product management, especially in conditions of high uncertainty, which is where we find ourselves. Another tool that I really like is this one by Gojko Adzik called impact mapping. And what he says basically is, let's start with the outcome we're trying to achieve. What's the customer or organizational outcome we're trying to achieve? And then, I mean, it's very simple. It's just like a mind map. Here are the stakeholders who can impact that outcome by helping or hindering it. Here's how they can do that. And then at the end, here are a bunch of features which could achieve that outcome. And what happens, you know, in any kind of unidirectional flow of requirements through the system is that someone upstream picks one of these things that they think will achieve this outcome, and then all you get as developers is that one thing. You don't get any of this stuff. This basically, you know, is just in the mind of someone upstream, and often you don't even know what the outcome is. I mean, who's seen cards where the so that is not there, or basically ignored, or written, you know, so that money. Okay, yeah, lots of you, right? And so actually starting with this and then working backwards and then saying, well, actually, you know, we think, you know, having a group of people, developers and operations people and product people in a room, putting this together and then saying, well, as a team, which of these things do we think will give us that outcome with the least possible work, which is really important, right? Minimize output, maximize outcomes, as Jeff Patton says. And then we're going to design an experiment to test whether this is the thing that's going to achieve this with the biggest bang for our buck. And we're going to find a way to fail quickly if that turns out not to produce the desired outcome and do something else instead. This is a much better way of thinking about things, I think. And it, you know, if you can pass this information downstream instead of this very lossy thing that we do right now, which is just to ship this thing downstream and say, build that. This actually fits quite nicely with this idea. We believe that building this feature for these people will achieve this outcome. And then we're going to design an experiment to validate whether that is actually going to give us the outcome we want. So very simple tools. You know, it's a mind map you can do on a whiteboard and a very simple template. And the point is not the tool, it's the collaboration across the different parts of your organization and the shared understanding of the outcome you're trying to achieve and the problem you're trying to solve in the minds of those people. Going back to that original idea of story cards as a reminder of a conversation, not as the canonical source of truth for what it is we're going to build. Probably the biggest gap in our training and knowledge as an industry is how to design experiments effectively. This is Janice Fraser's diagram, which I really like, which talks about user research. And you know, this is why UX is so important in our industry, because UX is basically a group of people who understand how to run experiments with customers. And she divides user research up into quantitative and qualitative, which are both very important, and evaluative and generative. In design thinking, typically they think about ideation in terms of generative. That's the first stage where you come up with lots of ideas, and then an evaluative bit where you decide which of those ideas you came up with is actually the one you're going to pursue. So design thinking talks about, you know, generation and then evaluation. And so these are the two phases that we see here in user research, ways of generating new ideas and then ways of evaluating which of those ideas are actually good that we should pursue. And you can see there's a whole ton of different ways that we can do user research. You know, surveys are one quantitative way of generating new ideas. A lot of the stuff in generating new ideas is qualitative. Things like contextual inquiry, which comes from anthropology, the idea that we're going to go and just study people in their natural environment solving problems in a very fly-on-the-wall kind of way, just observe them in their daily work and think about what they're doing. And various different ways to engage with people, like following them home, you know, with their permission, of course, not in a creepy way. But you know, going home and watching them interact with products in their natural environment is the idea, looking at mental models and so forth. And then down at the bottom, evaluative, ways of testing your ideas. So qualitative is usability testing, things like hallway usability, and then quantitative ideas like looking at key metrics and tracking them, doing analytics, and then the thing that's really the gold standard for evaluative is A/B testing. And the great thing about A/B testing is it allows you to actually demonstrate cause and effect relationship between a feature and the outcome you're looking at, such as, say, profit. So you're going to be very lucky. You're going to see Catherine Daniels talk tomorrow. She's from Etsy. I love Etsy because Etsy talks about all the things they're doing and publishes their slides, Creative Commons, and then I can steal them and put them in my presentations. So thank you, Etsy. So this is a slide from this talk by Frank Harris and Nell Thomas on Essence product development. This is how they do A/B testing. They basically have a very simple configuration file. This is like a few years ago. I don't know if you still do it the same way. But it's just very simple PHP where it's like, here's the config, here's the feature that we're going to test, here's the description, and then here's the percentage of users that are going to be exposed to that. And so when you visit Etsy, you get a cookie, and the cookie determines which set of experiments you're going to be subjected to, and that cookie is constant, so if you drop off the site and revisit, you see the same set of experiments, so the site looks pretty much the same to you. And then they track you all the way through using and interacting with the site. And so experiments are, we're not going to turn a feature on for everyone, we're going to turn it on initially to a small percentage of users, and then we're going to track some outcome metrics that we care about. So this, again, screenshot from Etsy, from the Atlas product they use to look at their experiments. Again, the resolution hasn't worked out very well, but basically the green line is the control, the blue line is with the experiment turned on. And what you can see here is, these are people visiting the cart. These are people bouncing off the site, these are the number of pages people look at, and these are the number of visits which end up with someone adding something to their cart, which are the business metrics you care about. In terms of the stats, this is done using students' t-test. What you're typically looking for is a 95% confidence interval to demonstrate statistical significance. And you can see only one of these metrics actually has demonstrated statistical significance. This experiment results in a 0.26% increase over the control in terms of the number of pages people visit on the site. So, that, for an A/B test, that's pretty standard. About a third of A/B tests don't give you statistically significant results. The ones that do, typically you're looking for, a percent or two is pretty good in an A/B test. Certainly for a product which is reasonably well established and validated, it's a bit different for where you're testing the whole product idea rather than feature ideas. But the great thing is you can actually see the outcome of the feature on the business metrics you care about. That, for me, is like crack as a product manager. It's amazing the number of times I woke up in the morning sweating because I had no idea if what I was building was actually valuable, versus being able to see real numbers that tell you the impact on the business of the feature that you're going to build. It's amazing, to the extent that I would never build a product that wasn't web-based if I could possibly help it, just because it's so much harder to get those metrics. And if you're building products for enterprise customers, it's much harder to do this. You just can't get the numbers to do A/B testing. And so you kind of have to fall back to one of these other things, such as the quite radical experimental approach of talking to your customers, for example. Still insufficiently practiced, I might add, in enterprise software. But you can still do this stuff. But A/B testing is incredibly powerful. Etsy has like a huge number of experiments they're running in production at any one time. Same thing in companies like Amazon. And this is one of the main reasons why Amazon do this. I love showing this slide. Who's seen this slide before? Hopefully a lot of you. Okay, not that many of you. So Amazon is deploying to production every 11.6 seconds. On average, they're deploying 1,079 times in a single hour. Sorry, that's the maximum of deployments in an hour. On average, 10,000 boxes receiving those deployments, up to 30,000 boxes receiving those deployments. And this is in 2011. Latest metrics are about an order of magnitude higher than this. So as time goes on, they're improving. This is one of the key things we measured in the State of DevOps report last year, was number of deployments per developer per day. And that's a really interesting metric. And what you notice about high-performing companies is that the number of deploys per developer per day increases as the size of the company increases. That's one of the characteristics of high-performing companies, as opposed to ones where as the number of developers increases, you don't see the number of deploys per developer per day actually goes down. So high-performance companies manage to enable their developers to move ever faster in terms of deployment, which is what enables you to gather more information from your customers on whether the stuff you're building actually works or not. And it's important to bear in mind, this was really hard and expensive for Amazon to do. They invested a ton of money on this. It took them 3 years to rebuild their entire architecture from very standard kind of N-tier model with a big Oracle database at the back to a service-oriented architecture which didn't have a single point of failure, which could scale horizontally. That was an enormous multi-year investment for them to do that. It was very expensive and very painful. But what it allowed them to do is basically take a much more experimental approach to product development. The guy who led the experimentation team at Amazon, then went on to work at Microsoft, a guy called Ronnie Kahabi. He actually coined the term HIPPO, the highly paid person's opinion. And he wrote a paper, he's written a few papers actually, but this is from a paper he wrote. Evaluating well-designed and executed experiments that were designed to improve a key metric, only about 1/3 were successful at improving the key metric. And if you extrapolate that to product development as a whole, what that's telling you is that you could be spending 3 days a week of your working week on the beach and deliver the same value to your customers if only you knew the 2/3 of the features you were building that delivered 0 or negative value to your customers. If you're not doing A/B testing, you're literally wasting about 2/3 of your time building stuff that's delivering 0 or negative value. People forget the negative value, right? Making things worse. You could be making things worse. It's not like, oh, no one will use this. It's like, this will actually make the experience of your product worse. And that kills us in 3 ways. I mean, firstly, there's the opportunity cost of not building something that would have delivered value. Secondly, we have to maintain those features forever. Who has deleted significant features from their software in the last year? Well, that's pretty good. I'm very impressed about that. That's the sign of a good company, is that you can delete the features that are actually making things worse. And the first step to that, of course, is knowing which features those are. And then, thirdly, those features have to be, they actually slow down the rate at which you can develop new stuff. So they reduce your velocity by adding complexity to your code base, which makes it harder to add new features. So this is, in my opinion, at least one of the biggest, if not the biggest source of waste in product development, is the stuff that we build that delivers 0 or negative value. Now, for years, we were told that IT didn't matter. Nicholas Carr wrote this paper for Harvard Business Review saying IT didn't matter. And so, for a long time, we kind of laboured under this misapprehension. I've been working on the State of DevOps report for the last 3 years with Gene Kim, Nicole Forsgren, Puppet Labs people, and we actually got some really interesting data the other day. In 2014, not the other day. Well, it was the other day, but it's quite a few days ago. So 2014, we got this really cool result. We measured organisational performance using some standardised metrics, profitability, market share, and productivity. And what we found is that firms with high-performing IT organisations were twice as likely to exceed their profitability, market share, and productivity goals. So in terms of how you get there, how you go from where you are now to being able to do A/B testing, this is really important. Being able to actually have high-performing IT, you've got to do that first before you start pursuing the A/B testing. You can't do A/B testing if you can't pursue, if you can't deploy multiple times a day, basically. What was interesting, apart from the fact we showed that IT mattered, was how we measured IT performance. We found a statistically valid way to measure IT performance. And we have lots of crappy measures of IT performance, like lines of code or hours worked. Who actually gets measured by lines of code? Anyone? Okay, a few of you. That's a terrible idea. What we want to do is do the least amount of work possible to achieve the outcomes. The best developers in the world are the people who can achieve the outcome without writing any lines of code at all, or preferably by deleting some lines of code. That's a definite gold star, right? So what we want to do, again, maximise outcomes, minimise output. So rewarding people for writing lines of code is a terrible idea. It produces the opposite outcome that we want to achieve. Nobody should ever do that in real life. How can we measure IT performance in a kind of system level way? This is what we came up with, and it turned out, we ran this survey. It's been run across 15,000 plus people worldwide across a huge number of different domains. And what we found is that we can measure people according to 2 throughput metrics. So lead time for changes to go from version control to production, and then release frequency was, hopefully that's pretty self-evident. And then 2 stability metrics, time to restore service. So when you have an outage or a reduction in service quality, how long does it take you to restore service to full quality of service? And then change fail rate, what proportion of your changes either have to be rolled back, or because we know nobody ever rolls back, like get emergency patches until they work. And what we found, which I think if you take one thing away from this is the thing that you should take away, is that high performers did better on both. We are really used to thinking that this is a trade-off, that if you go faster, you're going to break things. And the most important thing, I think, that came from the data and comes from continuous delivery as a whole is that it's not a trade-off. we can change the game. We can go faster and create more stable, high-quality services. And this is not without precedent. This is exactly what Toyota did in lean manufacturing. They didn't win by building shitty cars faster. They won by building cars more quickly that were higher quality and lower cost, all at the same time. That's what led them to win. And that's what led to the hollowing out and eventually the destruction of the US auto industry and the collapse of those companies in 2008, 2009, was that the game had been changed. And that's what we're seeing with DevOps and continuous delivery right now, is that we're changing the game. We're achieving higher throughput and higher stability and higher quality and at lower cost measured over the entire product lifecycle, although you do have to invest at the front end in order to get those benefits. So we wanted to see the things that predicted IT performance. And we use a model-based system for doing that. So we have a bunch of hypotheses. We test those hypotheses by doing statistical analysis of the data based on those hypotheses and performing regressions. And so these are the things that predicted IT, high-performance IT. Number one, I would recommend this organisation as a good place to work. It turns out that job satisfaction is the biggest predictor both of organisational performance, profitability, market share and productivity, and IT performance. Job satisfaction. Secondly, version controlling everything. And it turns out that actually version controlling, so who version controls their source code? Okay. Anyone doesn't version control their source code? Good, no one's submitting to that at least. It turns out, who's version controlling all their infrastructure configuration and application configuration? Okay, that's great, a good chunk of you. Turns out that version controlling your infrastructure configuration and your application configuration was more highly correlated with IT performance than version controlling your source code. And this is an example of one of these practices that helps with both throughput and stability. Because in the event of a failure or an outage, the only way you can deterministically restore service is if you're able to do it from version control using a fully automated process. If you have to log into those boxes and configure them manually, that's non-deterministic and highly variable. So in the event of something going wrong and you need to restore service, if you can restore service purely in an automated way from information version control, that's what allows you to be able to restore service in a reliable, deterministic way. It's also what allows you to do things like provisioning testing environments. Who's had to wait a week or more for a test environment to be provisioned for them? All right, lots of you. Who can self-service a test environment on demand? Okay, actually a decent number of you, about a third of you, I'd say. So again, if you can provision an environment, a test environment that's production-like from information version control, you can get feedback much more quickly, and that allows you to achieve higher throughput. So this is one of these practices that's really important in terms of both achieving higher throughput and achieving higher stability. And this is something you'll see in common with all of the practices of DevOps and continuous delivery, is that they both improve throughput and improve stability. If you're doing it right, you're not trading off one thing against another, you're fundamentally changing the game and improving your ability to do both things. The ability to move fast is basically the ability to get feedback fast. And getting feedback fast is what allows you to achieve higher stability, and the two things enable each other. They're self-reinforcing. Proactive monitoring. The ability to know that your system is down from your amazing monitoring system, not from, say, Twitter. High trust organizational culture, and then this is the DevOps piece, the win-win relationship between Dev and Ops. When things go wrong, do you finger point at each other? It was the stupid operations team, it was the ridiculous developers, they're terrible. Or do you actually find ways to solve problems together as a team? That's very important as well. So the third thing, which was really cool about this, was that we actually found a way to measure culture, which turned out to be statistically significant as well. We actually got this from John Allsport. I'm going to talk a bit about what culture is first. This is Edgar Schein, who wrote a really good book called The Corporate Culture Survival Guide. He says about culture that it's a pattern of shared tacit assumptions, and the tacit is important. You can't just look around and see culture in the way that you look around and see someone's t-shirt or whatever. It's tacit, it's invisible. That was learned by a group as it solved its problems of external adaptation and internal integration, that has worked well enough to be considered valid, and therefore to be taught to new members as the correct way to perceive, think, and feel in relation to these problems. And what's important about this I think, is the fact that your culture, if you're a successful company, your culture is the thing that's made you successful. So when people like me come along and say, well, you need to change your culture, what I'm saying is, you know that thing that made you really successful? Don't do that. Which off the bat sounds like a really terrible idea. You're going to be like, well, fuck off, Jez. And there's valid reasons why you would say that, actually. It's very dangerous messing with culture. It's very difficult, and it can actually have very negative results. So you've got to be very careful about it. So I just discovered a bug in my next slide. I said, what is ultra? Ultra is not a thing. Yet. This is a quote from Stanley Kane, who is a kind of enfant terrible of Silicon Valley. He wrote a really good book called Your Startup is Broken Inside the Toxic Heart of Tech Culture, which is as good as it sounds. And she says this: our true culture is made primarily of the things no one will say. Culture is about power dynamics, unspoken priorities and beliefs, mythologies, conflicts, enforcement of social norms, creation of in-out groups, and distribution of wealth and control inside companies. I think that probably has a visceral quality that many of you will appreciate in the audience, and it's something I'm going to return to at the end. So we found, you can't measure all of culture. There's tons of different models of culture. None of them are right. They're all just a perspective. I'm fundamentally Nietzschean about this. But the one that we picked actually came from John Allspaw. John Allspaw is he CTO of Etsy? Yeah, he's CTO of Etsy now. And he has this thing where basically you email him, you're like, hi John, how's it going? And you get back a PDF of whatever piece of research he's been reading. It's basically like research papers as a service. So I emailed him, like, how's it going, John? Happy birthday. He's like, read this paper. And it was a paper by this guy, Ron Westrom, who's a sociologist who's been investigating safety outcomes in healthcare and aviation, which are two industries where when things go wrong, people die. So safety, very important in these industries. And so he was able to basically create a typology that predicted safety outcomes based on these axes and divide up organizations into being pathological, bureaucratic, or generative based on where they fell here. And so, how we cooperate between divisions, this is a good one. What do we do when people bring us bad news? Do we train people to bring us bad news? Do we ignore them, or do we shoot them? How do people deal with responsibilities? Are they avoided? Are they defined narrowly, or are risks shared between people because there's a level of trust and cooperation that enables that? How do we deal with bridging between both up and down the organisational hierarchy and between different divisions? And then the two things that are most interesting to me, how we deal with failure and how we deal with novelty. So failure, how we deal with failure is really important. In a complex adaptive system, things will fail. It's inevitable. Complex adaptive systems naturally drift into failure, and so failure is inevitable in a complex adaptive system. Who's been involved in an accident investigation where something's gone wrong in your company and you had to find out what that was? Okay, which of those investigations ended with "it was Dave's fault"? not Dave specifically. That's why I used to use examples. I know that can never happen in real life. Right, so a whole bunch of you ended up under an investigation where it was X's fault. Those are shitty investigations. Because the question, what happens is, it was X's fault, they get punished or fired, and then someone else gets that job. And guess what's going to happen to that person? They're going to get fired too. Because the same thing is going to happen again. Because usually, it's not that people are dumb or stupid. People generally are smart and try and do a good job. The problem is, in a complex adaptive system, no one ever has perfect information, especially not the management, and every action will create unanticipated side effects that we couldn't possibly have predicted. There's fundamentally an asymmetry to cause and effect in complex adaptive systems. Looking back after an accident, it's really easy to trace the causal chains that led to the problem. Looking forward, when you're trying to do something, it's very, very hard, if not impossible, to see the chain of cause and effect that will lead to, one path of that will lead to some accident, and it's very hard to predict in advance. So what you've got to ask when something goes wrong is, why did that person not have access to the information they needed to make better decisions? How could we put in place systems that would have given them that feedback faster or prevented the catastrophic consequences that nobody knew about of those decisions? Any accident or failure should lead to investigation and improvement of the fundamental system. Failure should lead to inquiry. And then Most interesting for me is the fact that the same factors that predict safety also predict the ability to innovate. Environments that are safe are also environments where people are free to take risks and innovate because they have better information, and the consequences won't be catastrophic if they screw it up. And this was demonstrated by Google's research, which came out a couple of months ago, where they were trying to investigate how to make great teams. And what they found was the way that you make great teams, they thought, okay, get a few node developers and some people who can do, I don't know, databases and put them together in this proportions and you'll have a high-performing team. What they found in the end is that the biggest factor predicting high performance in teams was psychological safety, which exactly mirrors what we found in our research, is that the most important factor in creating high performance teams is psychological safety. And this is really important because we saw earlier that the highest factor producing organizational and IT performance was job satisfaction. Turns out the biggest predictor of job satisfaction is culture. And in turn, the biggest predictor of culture is job satisfaction. So job satisfaction and culture, again, are mutually reinforcing loops that together work to create high-performance IT and high-performance organizations. It's the most important thing you can do. So I'm going to false end my talk with a story from Amazon, from a guy called Greg Linden. So Greg Linden was a guy working on the checkout team at Amazon, and he had an idea. You go to a grocery store, there's like chocolate at the checkout aisle, and you're like, I'm not going to eat the chocolate. And then maybe like me, you have kids, and your kids are like, I want chocolate. And you're like, no chocolate for you. And they're like, and you're like, maybe you're a really bad parent like me, and you're like, fuck it, have some chocolate. So grocery companies make lots of money from doing this. And Greg's idea was, let's do this in a personalised way. Let's look at other people who bought the same things as you, see what else they bought, and recommend that to you. And so he knocked up a prototype and took the prototype to the VP of Products at Amazon and said, what do you think? And the VP of Products said, that's a terrible idea. It's going to distract people from checking out. They're going to abandon their carts. Do not do that. So Greg Linden's a bit sad, goes back to his desk, takes his prototype, brushes it up a little bit, pushes it into production, does an A/B test, gathers a bunch of data that shows that actually Greg's right and that this prototype significantly increases conversion. Goes back to the VP, shows the VP probably not very happy, but VP doesn't fire Greg and instead says, you should go ahead and carry on building this thing out, it's very important, and he goes and builds it. So I'm not going to say that this culture is ubiquitous throughout Amazon. Every company is very heterogeneous, and it depends where you are. But this was an example, I think, of the best of Amazon and these kinds of companies. I never worked at Amazon, but I have no information on Amazon. But he ends his blog post with this quote: I think building this culture is the key to innovation. Creativity must flow from everywhere. Whether you're a summer intern or the CTO, any good idea must be able to seek an objective test, preferably a test that exposes the idea to real customers. Everyone must be able to experiment, learn, and iterate. And it's this idea of taking a scientific approach both to process improvement and to product development, which is what software allows us to do, and making that ubiquitous throughout the organization and giving people the tools to be able to do that, that's really important. The other thing that I think is really important is something that Jack Andraka said, possibly the most important thing of all. He says, make sure to be passionate about whatever it is you get into, because otherwise you won't put the right amount of work into it. So one of my 2 closing thoughts is, think about if you had superpowers and you could do whatever you wanted to, what's the thing that you would go and do? And go and do that. So I'm going to return to my bug-infested slide from Shanley for a final thought. What is ultra? Well-known organisational metric. Where she says this, true culture is primarily the things no one will say. Culture is about power, dynamics, unspoken priorities and beliefs, mythologies, conflicts, enforcement of social norms, creation of in-out groups, and the distribution of wealth and control inside companies. So just look around you at the people in this room. What do you notice about the people in this room in terms of the demographics? Well done. Thank you for coming. So, when I wrote this, there's always the risk that you'll come into a room and it'll be, reflexive of broader society, and I'll be like, oh shit, I've got 5 minutes at the end of my talk. Fortunately, unfortunately, that's not the case. So you'll all notice there's a disproportionately high number of white men in this room. So, you know, some of my best friends are white men. It's not necessarily a bad thing. But, you know, it is a problem. There's no biological reason why that should be the case. It's clearly a function of culture. There's been endless studies done on this. It's not a biological thing, it's a cultural thing. So I'm just going to end with some kind of notes on this. We're very familiar with the idea that there's a talent shortage. You know, we have a talent shortage in IT. It's really hard to hire great DevOps people, for example, or continuous delivery engineers, or whatever the latest terrible job search title is of the day. And I want to point out that's not actually true. If we had the same proportion of women in this room and people of colour, we would not have a talent shortage anymore. And so I think that's the deeper problem, is the problem that people who are not white men are much harder to find them, as I'm sure you'll know. And also, they don't stay in the industry very long. The average tenure of women in the industry is half as long as the average tenure of men. And it's not because they're, you know, to pick on a really awful stereotype that hopefully no one holds, it's not because they're going off and having babies, it's because they're going off and getting careers in industries where it's less miserable for them. And so I think it's important to bear in mind it's not a talent shortage problem, it's a problem that we're doing a bad job of getting people into our industry who are not white men, and then a very bad job also of keeping them in the industry. And so here's 4 things that you can do to help fix that problem. Number 1, we've got to stop talking about individual productivity and 10x developers. Individual productivity is not a thing. It does not exist. There is no such thing as individual productivity. The only thing that is sensible to measure is the productivity of teams. Individuals can't achieve anything on their own. The way that the whole 10x developer thing, the whole way it was created, was basically getting a bunch of students at graduate school in computer science departments and measuring how quickly they could solve standardized tests. And what they found is some people were 10 times quicker at solving standardized problems than others. That is not what we do in this industry. We problem solve, we do heuristics, we work as teams together and solve problems. So those measures, those kind of 10x things, we need to banish that from our vocabulary. There's no such thing as individual productivity. Productivity is a team and an organizational outcome. It makes, like anyone who's doing individual performance reviews, that's a bullshit measure, doesn't measure anything. We should be measuring the productivity of teams, and we should stop talking about differences in individual productivity. That's something we should all be thinking about very carefully. Secondly, eliminating hidden biases. Now, we all know that hidden bias is an important factor in the way people perceive the people around them and their jobs. Do things like measuring things. Look for statistically significant differences in salary by role or by gender and by race, and then correct for those things. So, like, what you don't want to do is for people to find out they're paid less by someone else because they go for a beer one night and get very drunk and tell each other. That's a terrible way to find out, and people will quit when that happens. What you want to do is actually expose those numbers, not necessarily people's individual salaries, but by aggregate, and then compare them and look for those things and correct them in a very transparent way. And the earlier you start doing that, the less embarrassing it's going to be for everyone when you actually fix that problem. Look at tenure. Look at how long people stay in their jobs before they quit, and see if there are statistically significant differences, either by gender or by race. And also look at rate of advancement. That's really important. I had a friend who worked at a company where the VP of engineering quit, and they had to make someone the new VP of engineering. And it was really interesting what happened. They took someone who had never successfully done that job before and promoted them. And of course, that person was a white man. And that person actually eventually failed and got kicked out of the role, but they took a chance on this person. And what I noticed, I mean, we all know the stats, that there's a much lower proportion of women in senior management roles, but my personal experience from working in the industry for 15 years is that the reason for that is that people are much more likely to take a chance on a white guy than they are to take a chance on a woman or a person of colour, just because of generalised stereotypes basically about the performance of those people. You're much more likely to see someone say, well, you know, this guy, he doesn't have the relevant experience, but, you know, he's solid, you know, he does all the right things, and so he'll work it out. And my personal experience is that it's much less likely to see that people take a chance on women and people of colour. So that's something you can eliminate, actually in quite a simple way, by making sure that you advertise all internal positions to everyone in the organisation, and that you set targets for the number of people who apply for those roles. So you say, every management role, we're going to have an internal recruitment process, and there must be at least 50% not white men before we actually choose who's going to be chosen for that job. And then, by making it transparent, it then becomes very obvious if there's a bias in your process for promoting people. So start measuring your own performance and start setting goals, and they don't need to be 50%, but start setting some kind of goal and a horizon for that. And you're going to have to do some extra work to get that. I mean, yes, there are less women who apply for positions. What that means is not, oh, well, there's less women applying, so we can't do it. No, we're engineers, we solve complex problems, that's what we do. Let's put the same effort into trying to find people to fill our pipeline that we put into solving our software problems. That's something we should all be able to do. And then finally, invest in our people. So many of the problems in the software industry today have been caused by short-term thinking, people prioritising short-term goals over long-term goals. Why should we develop someone into the role when we can go and hire someone? Well, now, unfortunately, the shit has hit the fan with that one, because we can't hire DevOps people and continuous delivery people. So the alternative is what we're all going to have to do, which is actually invest in developing our own people. So that's something we should all be doing. How can we find people who've got some of the skills, mentor them, train them, give them the support they need, the 20% time, the investment in order to help them do that. Not go off in your own time and write open source code on GitHub, but actually we're going to give you real company time and resources to support your development, and we'd damn well better make sure that the people who we give those resources to are at least 50% not white men, otherwise we're going to do a shitty job. So those are some ideas on, actually, I think, not that hard things that we can do to fix this problem. And so this is what I would urge you all to do, is think about this problem, what we can all do to fix it. And thank you very much for your time, and I hope you have a fabulous conference.